Okay, excellent. I think we'll get started now. So I'd like to welcome you to tonight's Food Thinkers. I'm Professor Christina Vogel, Deputy Director at the Centre for Food Policy here at City University of London. And welcome to our May Food Thinkers. Our Food Thinkers seminar series will bring together big ideas from women in academia, policy, business, and advocacy in redesigning food systems. And I am absolutely delighted to welcome Dr. Cynthia Rosenzweig this evening to talk to us about breaking down food system silos. I have a little bit of timekeeping or housekeeping to do and keep to time to do before we get started. So just a few housekeeping notices. I'd like to let you know that applications are still open for you to join our MSc in Food Policy this autumn. It's an excellent program and there's a link to the program page that will be available in the chat box. It's just popped up now by my colleague Elaine. We'd also like you to know that if you'd like to receive our monthly newsletter and be the first to hear about our future Food Thinkers webinars, please sign up to our mailing list. And there's another link in the chat box for this newsletter. This webinar series is being recorded and will be made available online afterwards via our YouTube channel. So you can watch the end of it if you happen to have to dip away on time or watch it on catch up. Do tell your colleagues about the excellent seminar this evening if you get the chance. Please write any questions in the Q&A box. So this is very important. Please do not use the chat box, but try to keep your questions to the Q&A box so we can streamline them. These will be read out by me after Cynthia has given her talk. And we will try to cover as many of your questions as we possibly can in the time that we have available for discussion. If you'd like to tweet about Cynthia's talk, please use the hashtag FoodThinkers and the handle @FoodPolicyCity, all lowercase or one word. And just a final reminder that our next Food Thinkers will be on the 13th of June. And we've got Shakuntala Thilstead from the Consortium of International Agricultural Research Centres, who will be talking to us about her excellent work on aquatic food systems. So please do join us for that. But now I would like to introduce our speaker for this evening. So thank you for joining us, Cynthia Rosenzweig. Dr. Cynthia Rosenzweig is a senior research scientist at the NASA Goddard Institute for Space Studies. And that is co-located with Columbia University's Climate School Center for Climate Systems Research. Her specific area of expertise is climate change in food systems. At NASA, she heads the Climate Impacts Group. Cynthia is a co-founder and member of the Executive Committee of Agricultural Model Intercomparison and Improvement Project. In 2019, Cynthia was coordinating lead author of the Food Security chapter for the IPCC Special Report on Climate Change in Land. And she is also the 2022 recipient of the World Food Prize, which is also known as the Nobel Prize for Food and Agriculture. So we have a true celebrity with us this evening in the world of food. So welcome, Cynthia. I'm delighted to have you here joining us today.
Thank you, Christina, Professor Vogel. Welcome to, hi everybody. I'm in a hotel room in Washington, D.C. I'm attending, and this I think is policy, you could check this out. It's policy, very much policy relevant. I'm at the AIM4C Climate and Food Summit, which is a joint program of the United States and Abu Dhabi. It's strongly linked. It was founded on the US side by Secretary of State John Kerry through the UN Framework Convention on Climate Change, UNFCCC COP process. I think it was at the Glasgow one that I was at in person. And it's bringing together public sector, private sector, really work on scaling up where we are now in responding to the challenges of climate change in the food system. So with that, hi from Washington, D.C., and I'm going to now share my screen and launch into my talk.
Excellent. Thank you, Cynthia. just confirm when we can see your screen. Yes, we can see your screen.
Okay, and now there we go. And can you see all of it now?
Perfect.
Okay,
Perfect.
wonderful. So, Christina, Professor Vogel said that mentioned the Agricultural Model Intercomparison and Improvement Project. That's something I'm going to be talking about that quite a bit in this talk, but I'm never going to say the name again. It's called AgMIP. And so that's what AgMIP stands for. And I'm really pleased to be here in this wonderful series on food thinkers, breaking down food system silos, and to be included in the speakers in this seminar series. So let's look at pathways and partnerships. So first of all, we have to start always, I believe, with the climate change challenges. You know, now in a way, everyone accepts climate change, and often there are many talks about climate change that don't really show the climate changing. But that's what this is. That these first two slides are just bringing home to us globally, and think about the agricultural regions all around the world. That basically all of them are first of all already being impacted, and these are the projections for the future. So this is a very policy relevant slide, because on the left it is the projected changes. Again, look in the land, which has higher temperature changes, by the way, and the agricultural regions around the world. This is the simulated change of global temperatures at the 1.5 degrees C global warming. That is what the Paris Agreement is aiming towards. So you see, there would still be some warming in our food regions, but it would be under, basically, we hope, under control. The middle global map is showing 2 degrees. Remember, if you've studied the policy, the global policy agreement, it says well below 2 degrees, and hopefully when trying for 1.5. So the middle one is showing, the middle world map of temperature projections is showing the 2 degrees C global warming. This is, again, you see every half a degree matters. Just keep your eye on the agricultural region you're most familiar with, right? And then on the right hand side is, if the world really does not get its act together in regard to fulfilling the commitments for the Paris Agreement, this is what would happen to the temperatures with 4 degrees C of global warming around the world. Now, for the commitments, the nationally determined contributions, NDCs, that all the countries are making, have made to the Paris Agreement as parties to the Paris Agreement. If all of those work, and all the countries reduce their greenhouse gas emissions, right now we would be somewhere between the middle and the right-hand graph map of the warming. So the global policy is still not completely working effectively, and we have impacts of climate change on the road to our food system and our food production systems around the world. Now, of course, temperature is very important for crops, especially annual crops, but really all crops in terms of heat stress. But of course, water is also extremely important for crop production. So what these are the projections of the annual mean precipitation change at the same 3 levels of global warming. The blues and aqua colors are increases in precipitation. Yellows and browns are negative projections of negative changes in precipitation. Again, look to find your agricultural region of that you're familiar with, and see, is it brown or is it green? Now, even with green, let me just pull out in Africa, where there's a lot of high percentages, but precipitation is very low there already. For example, in the Sahel and West Africa, and that's not going to make that big a difference. Also, increases in precipitation can cause waterlogging and flooding in fields. So not necessarily, oh, this is going to be great for agriculture. And then, of course, look at the browns for the areas that are projected to get drier. And in particular, you can see the Mediterranean region is building up to have decreases in precipitation. And of course, we all love our food from Italy, for example, but also North Africa, issues there. So these are what the projections of the climate change challenges actually are for our regions around the world. Okay, that was the intro. I'm going to talk about, this is, so when I was so fortunate, I'm so thrilled and honored to be the 2022 World Food Prize laureate. And I did a lot of interviews. And one of the frequently asked questions, you know, those FAQs, was, well, as you were going through your research on climate change and food, what were the aha moments that really occurred as I was studying this and doing research with this? So I'm going to share with you 4 aha moments. The first one is the vulnerability of developing countries to climate change. I'm going to share the very first work that showed that. The second aha moment is the creation of the AGMA multi-model approach. This is a science thing that improved the rigor of how we project impacts on food. The third aha moment really started about 5 to 10 years ago, when the climate extremes, like rate of change, appeared to be getting faster, and those climate extremes coming more rapidly on our food regions around the world. So before that, there had been, oh, it's in the future, 2100, but then the third aha moment is this realization that this is all happening faster and worse on our food system. And then the fourth aha moment is flipping the turning the crystal to look at the massive role that the food system plays in greenhouse gas emissions. So the first 3 are more about impacts of the changing climate on the food system. The fourth is flipping that crystal to look at how the food system affects climate change. And then ending with where to from here, including policy. Very, very important. Okay, here we go on the aha moments. First of all, the aha moment number 1, developing countries are more vulnerable. So this is the very first global study. It was published in Nature, in the journal Nature, in 1994. And the co-author, my co-author on this paper was Martin Parry, who's a Brit, who was the co-chair of the IPCC Working Group 2 for the 4th assessment report. So when these results were done with researchers all over the world, and they sent in their results, and we made the very first version of these maps by hand, back in the dark ages, before we had all the fancy technology to make. You're going to be seeing some of the videos coming up. But if you look, just what the columns are showing is first the potential change in grain yield for climate change without carbon dioxide effects. That's all brown, but high CO2 helps with yields. So the middle column there is with the CO2 effects. And then when we got those results, you can see, look at Africa, look at Latin America, across 3 different projections from global climate models. The UKMO is from the Met Office in the UK. And you can see that the darker browns, the yellows and browns, are in the developing countries. And this was one of the key lessons that came out of this first global study. What the right is showing is that, of course, farmers are going to adapt. One of the mantras is there are no dumb farmers. So right away from the very beginning, we studied adaptation. And that's what adaptation level 1 is less adaptation, and adaptation level 2 is more adaptation. But what you can see looking at that right-hand column, look at Africa again, look at Latin America again. You see that the preponderance of countries there are vulnerable to climate change. Now, fast forward now to now, there have been hundreds and hundreds of many regional studies on climate change in developing countries. This is showing a wonderful project that was funded by the UK then DFID, now which has been incorporated in the FCDL. And this was with teams in West Africa, Eastern Africa, and in South Asia. And all of this is documented in the books there. And what did we learn? After hundreds of studies, and this is just one example, and working with stakeholders, et cetera, working with smallholder farmers in developing countries, all of these studies show the same thing. Developing countries are still more vulnerable. That aha moment has not, and that finding and realization in the aha moment number 1 is still true. The developing countries are still more vulnerable. Now, of course, and we still work on adaptation. So, you know, we worked on adaptation because there were no dumb farmers. So we always we worked on adaptation in the beginning, and we still work on adaptation. What the animation is showing is working on current climate variability for Ghana. This is the Enhanced Vegetation Index, showing year by year what's happening in regard to droughts and wetter and drier years. You see the variability that that governments are, farmers and also their governments are dealing with now. On the right-hand side is showing from the same set of studies funded by UK DFID, what happens when you project without adaptation, and with adaptation, you see the methodology is still the same. We see that with adaptation, there's potential for adapting to the projected changes, but not in every case. And in this case, you see maize, even with adaptation, is not doing well. So the finding is the same on adaptation. Adaptation packages can raise incomes and lower poverty rates, but do not always compensate the crop yield losses completely. Let's go to aha moment number 2. So here's the question: what's better than one model? And the answer is dozens of them. So all that work that we did, that I showed you in the early study, was only done with one crop model. But what we started doing was, when we started gathering all the models and modelers of the world together, and we started developing protocols with them, so all of the models across different kinds of models would do the same thing, that would follow the same rules in their simulation studies. And what we found was that the ensemble mean of the multiple models predicted yields more accurately than any one model. And that's what this graph is showing. In vastly different food growing conditions, from high rainfall, very productive areas in the Netherlands, all the way down to very dry areas in Australia, we have tested this with multiple models, and we find, and we also test with when there's not very much data, that's the wide bars. Then when there's more data for the models, then they're more narrow. But in every case, the ensemble mean is closer to the X mark than the range of models, than any one model. And these are under the very different growing conditions, and that's true under the poorly and well calibrated conditions. So this improved the rigor tremendously of projecting how climate change would affect food. So what we did then was, as this was one of the early studies after the founding of AgMIP in 2010, and so we now have a wonderful network of agricultural researchers all around the world It's completely open, completely transparent. And we get together and we work on these kinds of model assessments, model improvements, anything that's important to do. We make teams, AgMIP makes teams to do it. So this is to prove that we have over 1,200 members in the network. During COVID, here we are all on Zoom. That was the 8th Global AgMIP workshop, which happened virtually. We have the crop teams. Here's the crop team, the wheat team that did some of the people who did that study that I showed you on wheat. So the mission of AgMIP is to provide science-based agricultural decision-making models and assessments of climate change to achieve local to global food security. So AgMIP works on all scales, really. Down right at the farmer level, this was a workshop that we held in Nepal. But all the way up to the global, we have the global crop modelers, we have the global econ modelers, and we have national scale models, and we work on the interactions across those scales so that it's a very integrated systems approach. So speaking of the science approach, here it is. There are 2 tracks. One is the track 1, develop and test next generation agricultural systems models. I was showing you some of that. That wheat study was just looking at current climate. And then what we do is then in track 2, we conduct multi-model assessments for sustainable farming systems and climate smart agriculture. Look at that green square right in the middle. Here's one of the secrets of AgMIP. We don't just do this for crops. We do it, we have economics models, we have livestock models, we have pest and disease models, every kind of models. So, and the experts, it's the models and the modelers that really are creating this new way of working together in what I call radical collaborations. On the right-hand triangle is our AgMIP Sentinel sites data. Of course, everything is data now, big data, and searching it. And now by the way, we're doing AI and machine learning across the data, across the sites, across the models, across the observations. So this is like how the science is actually conducted. But very, very briefly here, I just want to say, remember when I read you out the name, the I stands for 2 things. It not only stands for intercomparison, that's what I've been showing you, but also improvement. So here are some of the studies documenting that we work on improving the models too. We can't keep using the same models over and over again. We have to keep improving them. So one is on to improve temperature response. That's global warming, right? It used to be called global warming. So the models have to do a good job on that. So we had a wonderful team working on that who delved into that. We also did the CO2 responses. Remember, I showed you with and without CO2 and that very first global maps, very important to get the CO2 effects right. And then the wheat team now has over 100 members and lots of model improvements going on there. And this is even more things that AgMIP is doing. We call this the petal diagram. And all of these elements we have teams working. So if there's anything from any of you that are working on any of this, please join AgMIP and be part of one or more teams. It's a great network to be part of too, that and really share and improve everyone's work. It's not at all about any kind of, we call it bake off. Oh, remember like that, that great UK baking show that everybody loves now in the States. It's not a bake off. It's not, nobody wins at the end. It's about improving the models because those models are embedded, the knowledge in the models are embedded knowledge that we want to then improve and use in a better way for all the different food and agricultural food systems around the world. But just to pick up, so we have water resources, livestock, scaling up, all these different crops, evapotranspiration, but also the global economic assessments. We have regional teams. I just met in the hallway the Latin American and Caribbean colleagues who are working on AgMIP in Latin America and the Caribbean now as well. Just met them like right before I came up to give this talk. Okay, let's move on to, that was multi-model approach. That was aha moment number 2. Aha moment number 3. Climate change is happening faster and in more extreme ways. So we all know this now. So the urgency of responding to climate change is growing basically by the day, week, month, and year. So these are data from our institute, which is NASA Goddard Institute for Space Studies. This is the temperature change over land, because that's where the food, I'm not doing, I think your next speaker in June is going to be, I think it's also another World Food Prize winner who works on blue, what's known as you know, blue food. But this is over land. And what you can see is starting in about the 1970s, this temperature change, of course, with ups and downs through the years, has really taken off in terms of rate of change. So we've really now have to mobilize and scale up our responses because the climate is changing really faster than the original rate of change starting in 1880. Roughly when a lot of the measurements were started. But the thing is, that's just the mean temperature over land. But of course, we all know what affects agricultural regions so much is the extreme events. So here are some of the key ones that I'm sure you're very aware of. 2021, Madagascar began experiencing what was called the world's first climate-induced famine. In Pakistan, I'm sure we all are, so cognizant of the 2022 enormous flooding there. In Europe, 2022, also the severe lack of soil moisture with heat stress on crops. That was in July of this was just even last year. The heat wave, prolonged heat wave in Europe, heat waves in Europe. And then in the US, this was Hurricane Ian in 2022, affected over 350,000 or 375,000 acres of citrus. So these extreme events are becoming absolutely more critical in regard to pressuring the food security around the world. Okay, so remember that first map that was done and published in Nature long ago in the 90s? And this was what was brought, this is the video of the same thing with the current climate projections. We start in 2022, we go to 2099. And the thing to look at is at the top right, we have wheat. At the bottom left, we have maize yields. Look at the regions around the world. They vary. The projections still vary by region and vary by commodity. And certainly in the case of maize, look again to see if the results show developing countries are vulnerable. So here we go. So we're going, this is with 5 global climate models, 12 global gridded crop models. This is without any adaptation, because this is, again, very similar to what we were looking at with the climate, those climate effects. And this is more like what's happening with that 4-degree warming global average. This is what the farmers and the farming regions will be facing if the policy process doesn't work. Here we have up to 2099. We still see some areas that wheat does a better job in the mid and high latitudes, but lower latitudes still for the wheat, certainly in the Indian subcontinent, negative on the wheat as well. Some negatives there too in developing countries. And you can see then maize suffers almost everywhere. But again, you see developing countries very much affected. Okay, let me get out of this and go to the next. These results were were published very recently, just a few weeks ago, in the IPCC AR6 synthesis report. They were summarized over roughly those similar temperature groupings to show the maize yields. This is a summary from the video that I just showed you. Our work is the work that we do when sometimes people say, well, who are your stakeholders? So we have stakeholders at all the different scales and levels. I think for you all interested in policy, that's very important. Always, so who are those stakeholders? Who are those policymakers, decision makers? And this work is, in this case, these global assessments really are to the parties of the UN Framework Convention on Climate Change as through the IPCC in their assessment reports. Okay, aha moment number 4, massive role of food system emissions. Remember, we're turning the crystal around because, and here's the food system that you study in your program. Here's our take on the food system with all the different parts and the connections. And working with FAO and others at Columbia, at the School for International and Public Affairs, what we do here is we work on analyzing and estimating the emissions from all these different boxes. So from the pre-production, fertilizer manufacture, equipment, and manufacturing the equipment, the food-related, deforestation, expanding rangelands, draining wetlands, draining peatlands, peat fires, burning savanna. All these are, and I won't go through every single box because that'll take all the time this evening, but maybe you can also find in this box, which area are you working on? The whole food system, or is there a box you're working on in your work, if you're working both on the impacts and resilience side and adaptation side, or on the mitigation side? Because all of these elements in the food system are contributing to greenhouse gas emissions. So we did all this. This is what we did for the IPCC as well. We added it all up. And when you look at these activities, the food system as a whole contributes about 1/3 of all human-caused greenhouse gas emissions. So basically, the take-home point here is climate change cannot be solved unless the food system emissions come down as well. So this is with working with the FAO. If on this topic, what this is showing is for Annex 1, which is the developed countries, and the non-Annex 1 are the developing countries. Those are UNFCCC designations across agriculture, energy, land use, land cover change that we were just looking at in the boxes. And this is with them, we created a database looking at what were now we're comparing what were the emissions in 1990 and compared to 2018, and it's now been updated, I believe. But what do we see here? Which are the highest ones? They are the two are enteric fermentation that's from ruminants, of course, beef and sheep and other ruminants. And then the net forest conversion is also still very high. That's the clearing of land for agriculture. And what's interesting is to look to see what's happening in the developed countries. So there, in the enteric fermentation, this is actually coming down. This in 2018 is lower than what it was in the 1990s. But for the enteric fermentation, the greenhouse gases in the developing countries, with the development and economic development, there is more meat in the meats and in the ruminant meat in the diet, and that is actually those greenhouse gases have been increasing. On the other hand, the net conversion for agriculture has really come down in developing countries. So that's real progress. So I think there's some lessons to be learned here about which we did it. The database is country by country. So every country has to think about what they want to do in regard to their nationally determined contributions, right, related to their food system emissions. And even then, it's coming down a little bit in the developed countries as well. So there's really quite dramatic progress in the land use change for agriculture over this period, 20 years or so. But the meat eating is still emissions from ruminants still on the rise. Okay. So those were the 4 aha moments. See, in the beginning with agriculture, it was buried. By the way, let me just say one more thing about this. It was kind of buried. People weren't really looking at it. They were just doing agriculture production. But really, when we then step back and say, no, we should really consider this all as the food system, that's when this realization came that the food system and climate change in terms of a causative factor is enormous. Okay, where do we go from here? 3 things: mitigation and adaptation, multi-scale assessments, which I mentioned before, and science and policy. So this is coming from the IPCC Special Report on Climate Change and Land. And a chapter, what they did was they looked at practices that could do both mitigation and adaptation. So the green stars have positive adaptation benefits for more than 25 million people, and the red stars have mitigation potential for more than 3 gigatons of CO2 equivalent per year. And so we've just highlighted the 3 at the top. Increase soil organic carbon content, which is very challenging, but still has great potential. Increase food productivity, because if we're being more productive, we're capturing more carbon actually in the soil. We are not having to we can reduce our deforestation for agriculture. And then agroforestry. That's really important because, those trees suck up a lot of carbon while they're growing. So those are the 3 that have the biggest. There's many other possible, positive things that you can see on the list. So what we've done in AgMIP is bring these 2 together, and in developing protocols to look at both bring together the models that do emissions and mitigation techniques and practices with the impacts and adaptation models. And we're bringing them together, sometimes in the same model, sometimes in different models, but looking at these together under changing climate conditions, because it's all one system. So when we go, for example, we have a project now in Bangladesh. Oh, and I'm going to show you some in India in the next slide. But, it's like, it's not like, oh, we're doing something for mitigation, we're doing something for adaptation. It's all one system, and we really need to think of them in an integrated way. Also, just to show you, we're now, of course, including gender, including nutrition. So all with food security in mind for those. This is where their work is going now in developing countries. And down here, policies and programs, because in the end of the day, all this modeling, unless it gets used and in policies and program, if it providing that scientific base to really solve the issues of climate change, then it's a success. Otherwise, it's a box and arrow diagram. So that's why what you all are learning about in your program is so important. Okay, I won't go into all of this, but just to say we're doing MACB. We call it MACB, which we have to change the acronym because it sounds like a McDonald's hamburger or something, which is not good. So we're working on changing the acronym, but we called it Mitigation and Adaptation Co-Benefits. And in both Bangladesh and in India, we're working on rice systems. And with the alternate wetting and drying rather than the flooding in the paddy rice, which causes higher methane emissions. And what we do with the models is then we can see, and the climate change scenarios, well, how do these packages of mitigation packages, adaptation packages, together, what effect do they have on yield? In this case, it's improving the yield and decreasing methane emissions. So that's what we're working on, providing evidence base for this kind of approach. Multi-scale assessments. They've got to be stakeholder driven, focusing on farm systems, development pathways. What does any region, what do they see? We work with, what do they see for the future of their region? We bring together biophysical scientists, socioeconomics, whatever your backgrounds are, you can be on an AgMIP team. And we do this across scales and models, field, farm, regional, national, global, and multimodal, so that it's rigorous science. And by working with economists, we are able, and that's what this all is showing on the left, is we're really able then to look at distributional effects on poverty rates, on welfare, because not every farmer across this landscape is going to be reacting the same. We stratify by often income brackets, how many cattle, many things. So we're really now able to really delve in to see what we can really do to scale up responses in the developing countries. Remember, that's where the vulnerability is. We also do it in developed countries as well, but so important to work with smallholders. Okay, here is the science and policy part. So we wrote a paper called Finding and Fixing Food System Emissions, the Double Helix of Science and Policy. It was published in Environmental Research Letters. Here's a diagram from it. So what are some of the ways? So you see this double helix of, before I think the scientists would do their work, and I call it throw it over the fence. But right now, given again the challenges, the decade of action, the absolute urgency of responding to climate change, we don't have the luxury of having the scientists work for 5 or 10 years and then go, okay, here policymakers, here policy specialists, okay, you take it away. So we need to be, so let's look at how do we do this? So first of all, the scientists provide the evidence base. They inform evidence-based policymaking. That's really what I've been showing you in this talk. For what do the policymakers, policy specialists do? The policy experts inform impact-oriented scholarship. It's like, okay, what should we be studying? We'll be studying something that's of intellectual interest, but by working with the policy from the beginning, we're going to be creating the studies that are actually going to be able to be used by policymakers. So we need that input from the beginning, right? For mitigation and adaptation both. And then to say this has to be interdisciplinary in convening the stakeholders from climate, energy, food systems, and nutrition, all at the same time. And that's really where AgMIP is going now. So final thoughts. Take food system approach that links to climate system, ecosystems, nutrition, sustainable development pathways. I'm wearing my SDG pin in order to achieve healthy food and a healthy planet. Keep a laser focus on climate change solutions for food system stakeholders with an integrated focus of mitigation and adaptation. Finally, remember back to the climate extremes. This is happening now in food system and food regions around the world. Conduct multi-scale assessments of solutions, right? That's where we are, including resilience to climate disasters in the food regions, food regions around the world. And my ask, so this is finally circling back to the World Food Prize, people would ask me, well, what do you want people to do? How do you want to solve climate change? And my ask is that we create larger scale climate change solutions. So that's my challenge to you. If you're doing your master's project for your thesis, how about a big project rather than a small project? Or how do we scale up? Or if it's a small project, think about how can this be scaled up so that we get the implementation, the responses, the solutions to climate change that we really need. Think back to that map. We need to solve the food emissions. We need to solve the resilience so that we can be, and in the policy, UN Framework Convention on Climate Change, Paris Agreement, we need to be in that left-hand map, 1.5 degrees C, and food system has to help. I'd like to invite you to come to AgNIP 9. It's our global workshop. It's going to be in person and virtual, both. June 26th to 30th. If any of this interests you, please come along. It's a great workshop. It's meeting coming out of COVID too, meeting people again. And we're going to be doing virtual breakouts so that you can actually, even if you're coming in virtually, really be part of it. Because that was, just missing those in-person interactions. Now we have our hybrid world to make this work. So I invite you to come. They're wonderful, wonderful workshops on all of this and more at Columbia University in New York, June 26th to 30th. You can, 1, 2, 3, 4, or 5 days. And I want to thank you so much for inviting me. I can't wait to hear your questions, comments, and please join AgNIP. And get protocols, up-to-date events, and news. Thank you very much.
Wow, Cynthia, thank you so much. What a fantastic overview of a life of work, of hard work, of really identifying some key areas of the food system that need improvement. And as you say, it's not just one area, it's across the entire food system, isn't it? So thank you so very, very much. A massive round of applause to you virtually. Thank you very, very much. We've had lots of comments and questions coming in, which is very exciting. So please keep them coming. Please do use the Q&A. So I'm going to get started. Some of them came in a little bit early, so I'll be reading them all out and you can address them all. So first of all, from Lopa Saxena, she has asked, to what extent are diversified farming models included in the study, and which is different from single crop and single livestock models?
Great. Okay, why don't you give me 3?
Sure.
Should we do it that way? Let's do groups of 3.
Yep, so then we've got next from an anonymous attendee here, who is asking, do the models, sorry, it's jumping around a little bit, do the models only take temperature and mean annual precipitation into account, or do they also include things like precipitation, variability, and pest pressures? And if it's just the former, do you think we're likely to be surprised by factors that you're not currently looking at? And then a third one by another anonymous participant we've got is anyone on your team thinking about how recent developments in AI could help this project? And you did mention AI in your presentation. So right, hand over to you.
Okay, wonderful. Great questions. All right. The first one is on the diversified farming systems. Absolutely critical. And I'm so glad you asked that. And so I was in a session today at AIM4C. And by the way, definitely all of you check out AIM4C Climate Summit. It's really, so it's streaming now. It's going on to tomorrow. Yesterday, Al Gore and the Secretary Vilsack, we had a great round, fireside chat, lots of different things. But in our session today, which is about a new program for traditional and indigenous crops for Africa, we got asked the same question, and this is very, very critical that some of the models are able to do more than one crop. There's one model called APSIM that does, others do not yet. But this is very key, and that's why we have the eye for improvement, because we have some, but then if it's only one model, we don't get that wonderful multi-model rigor. So we're working on that one. Thanks for raising it. The second question, also very good modeling question, is no, I just showed those global mean temperatures and mean precipitation, but the models take on a daily basis temperature, precip, solar radiation. And those are the main ones that they take. And so we get, and when we do the change, when we take the climate change scenarios, we include, we create the climate change scenarios with the changes that are projected in climate variability to get the changes in those extreme events? So very, very good question. The answer is really yes. And on the pests and diseases, because that's so important, so I know those are often, they're also counting up, those models need to have like sub-daily, like hours of certain humidity, for example. So we have in AgMIP 3 or 4 teams that are only looking at the pests and diseases, and then also then seeing how they will change with the regular models as well. So pests and diseases, yes, definitely, absolutely critically important as we change those agroecosystem envelopes, right, around the crops. And then, so thanks so much. AI, machine learning. Yes, absolutely. So, and if any of you we have this great, we've started it. My colleague, my co-leader and the science coordinator of AgMIP started it. We're having a session at AgMIP 9 that I invited you all to. So please, come online if you can. And, if you want to do like a cohort, Christina, because we have to pay for the catering, etc. But if you all wanted to form like a small group, we could see about you all coming like to that AI session. We'd love to host you, and without paying for that. So it's very interesting because how to really use it. So the way we're using it so far is we take remote sensing data, we take observed yield data, and we take the crop model results. And we take those 3 streams, looking to see what the correspondences are. And then what the outcome is that they are identifying which areas in the crop models we need to improve. So it's being very helpful for the eye for improvement. That's so far what we're using them for.
Excellent, excellent. So yes, please do attend in June at the workshop if you're interested, and lots of interesting discussion there about AI. So lots more questions coming in. Please do keep putting them into the Q&A. So Jeff Townsey has asked, what do you think of the Rethink X work, arguing that disruption in food systems, thanks to precision fermentation, will see the end of animal farming as we know it by 2030? With much of the land use to feed animals released from production. This, along with other disruptive technologies, they argue will tackle climate change and radically change the agricultural and food systems. So we'll go for, shall we do a 3 again?
Yeah, let's do 3.
So another anonymous attendee, does increased food productivity include increasing the proportion of crops grown for human food as opposed to animal feed? And then the third one is another anonymous attendee. This kind of transdisciplinary team science is wonderful, but I found it challenging enough in teams of just a few people. Can you say more about coordinating thousands of participants? I had exactly the same question. How on earth do you manage that amazing collaboration effectively?
Great. I call it radical collaboration. All right. Wonderful. These are great questions. Fantastic. All right. Yes, this disruption thing. I know, so challenging. So I spoke at I've given a lot of talks this year, as you can imagine. But by the way, the new World Food Prize is going to be announced. The winner for 2023 is going to be announced on Thursday. That's one reason why I'm in DC. But anyway, so my intense year is just this. I think this is my last talk that really has come from it. But I gave for the American Association of American Geographic Society, because geographers are really very good, and maybe some of you have a background in geography. It's very good on all of this systems thinking and biophysical and socioeconomic. Anyway, so I gave a keynote there, and then right after that person on the disruption and the fermentation, the fermented food and all of that came, and I'm going, oh my gosh, so, but I think it's very similar to AI, what's happening now, especially just like even the last couple of months, right? With chat GPT and all of what's this, the new search, the new coding, our world is changing. It's like, as you all are, I'm sure you have heard it and are discussing, it's like the printing press, it's like alphabet, it's like we are now together going through this human transformation. And so I feel like, it's what we need, how do we navigate, right? So I guess the way I feel, this is just very personally, we're doing all of this because the systems are still, our models are from the systems that are in extant now, right? But we're definitely speeding up with AI and machine learning to be able to respond to potential disruptions. In a certain way, we've learned a lot from studying climate change, because climate change is a major disruption on the food system. So we have a lot of experience of dealing with disruption now on the food system. And in a way, if that technology changes, that's where I would say we have at least some clues about how to do it. But, I think we need to be open to it. I think it's really interesting and cool. And, let's see what happens. That's how I feel about that. But it was like back to back. So it was really like, oh my gosh, it was great. Okay, second thing is, the second part is very, very important. And that's why I showed this data about, this is about increasing productivity and these use of the land for human versus animal feed. And this is very much has to do with that graph I showed. So we have the enteric fermentation. So having that, we need to have a lot of food to feed the animals, right? With dietary change that's occurring. That's what the trends are showing in the developing countries as they develop economically. And then we saw those two big ones were then the land use change, which is then, we need more food. If we need more food for animals, that puts pressure on the natural areas, and with higher emissions as well. So that whole land use balance is very, very important as we think about the food system really responding. Just one part there that I want to emphasize one thing there. So all of this, again, just as we were talking about, well, are we going to ferment? So if we go to fermented food, then maybe this is not going to be important, right, in the future. But right now it is. But we have to be, I think, also very careful about being prescriptive about people's food choices, people's food environments, people's development pathways. And I really believe that we need to be finding just transitions if they're with food system transformations, which is a very big topic of discussion right now, that has to be done in just and equitable ways. So that whole, but it has real consequences in regard to the human versus animal feed land use choices as well. Okay, third question. Teams, how do we do it? That's great. It's really fun. So I'm a firm believer in networks, and I think networks are really this. And I'm a firm believer in collaborations. That we cannot solve climate change and food unless we collaborate. And so one of the things that we're doing at AgVip 9 is we're having sessions which we call radical collaborations. And so what we're doing, one of the things, this is one of the things we do, is we're bringing the groups together, because the groups really are used to working together. Like and I'll give you the classic one. So we have our crop modelers and we have our econ modelers, right? And sometimes they, like the econ modelers have said, and, apologies for any economists in the audience, the economists would say, no, we have to just talk to each other. We cannot start talking to the crop modelers. we can't. So, they would be refusing. So, but, never give up. That's one of my mantras. So what we do, so we start to create dialogues that's one of the ways that we do it. Another way is, I think, on the network side, is networks have to be good for the people who are in it. And Martin Parry, whom I mentioned, a wonderful colleague from the UK, one of the very first segment meetings, at the end, he got up to give his remarks. He said, "Why are you all here?" And he said, "You're here because it's going to be good for you in your work. And you're going to learn." And you see, so it's great you're in your program, right? People in the program 1 year, but then now, especially with all these disruptions and that we've been talking about, right? We got to figure out how to learn through our whole careers, our whole lives, right? So that's why these networks, I think, can be very helpful. But I would just always say, AgMent network in action. We're always thinking about that. So, we write, we have people get who are doing the modeling work. These people, those global gridded crop modelers, their work is in the IPCC together. They got something from doing it all. So that's one of the secrets.
Absolutely. Mutually beneficial outcomes, hey? And genuine curiosity. Love it.
Yes. And learning, mutual learning.
Yeah, mutual learning. Absolutely. So thank you very much. The questions are piling in, so I'm going to keep going. So we'll go for another 3. So another anonymous attendee we have, you identified agroforestry as a practice with adaptation and mitigation benefits. Agroforestry always seems like one of those things that really should be done, but doesn't get much traction in practice from a US perspective. Is the situation different somewhere else in the world, and what policies, etc., can be used to encourage agroforestry? Second question from Natasha Grist. Thank you, Cynthia. What an amazing presentation. Would you say something about how we can engage effectively with the reality of policymakers' decision-making, which is often not rational in following the models that you might suggest? And then the third question from Peter Golden. Which developed countries have the largest ruminant emissions increase? In Brazil, categorized as categorized as developing? NDCs monitor production, but who quantifies the profits from the beneficiaries of the beneficiaries? And could pricing consumption help reduce emissions?
That's a multifaceted question. Okay. Oh, wonderful. Okay. Agroforestry. So take a look, and Christina, maybe what we could do is post the food security chapter from the IPCC special report on climate change and land, because that's where it talks about agroforestry. I agree with you, not a big winner in the United States, I would say, but in my coordinating lead author, whose name was Sheikh Mabou from Senegal, he came from ICRAF, the CG Center that works on agroforestry, and in Africa, and we have a whole box there on the benefits of agroforestry, both from mitigation side, right, because it's storing the carbon, but on the adaptation side, it's, for example, by having the windbreaks, that's slowing down the evaporative power of the wind, for example, and therefore helping on soil drying. For example, and then also because of products from the trees, for smallholder farmers. So agreed on, so those are some of the ways that they help both with the mitigation and the adaptation. Look at that, and particularly in Africa, it's being very much brought forward as a solution. I would agree, less so in the United States. Okay, next is reality of policymaking. Yes, so policymakers are right. They're getting right. So many different groups and factors and influences, right? That it's challenging. So I guess just a few things from AgMIP is to engage, and long term, if as much as possible, develop longer term relationships. That's one. The second is listen to what the policymakers really need. So sometimes we get a call like that, like I call them fire drills. We get a call from someone in the US, let's say this is with our US policymakers, stakeholders, and they would say, okay, you say that agroforestry, well, let's use it. You say agroforestry can store this much carbon. Okay, give us the exact numbers by tomorrow. So there's this longer term relationship, but it's also okay when they ask you something, dive through the window's open, you have to dive through it. And then also we in working with other countries, we develop a actual stakeholder engagement process. There's on the AgMIP website, you can find the protocols for stakeholder engagement. And we're actually at the global workshop, we're having we're going to be updating those, and the group is getting together to do the updates. So, and we work with social scientists. I'm sure many of you are social scientists. And we say, okay, how do we really do this? How do you work with policymakers? We're not just like, oh yeah, we're throwing our, here it is. We did this. We did all this modeling. We're throwing it out the window or over the fence and, pick it up. It's not like that at all. And another thing is, final thought on this is capacity building, developing modules and capacity building for the decision makers themselves, because like utilizing evidence base, right? They don't necessarily know how to use it. So I think there's a very fruitful area. I think it's a great question, but all these things and all multiple things. Okay, final thing is, okay, so these were some very specific things. So questions on the database that I showed. So please look at I can post it. We can send to Christina. All of the data is the FAO FAOStat database. I believe they just have released a new 2023 version, or they are certainly going to do that soon. That was supposed to happen end of April. So I don't want to say how Brazil, you can then compare, and that would be a good homework question. Which from that database, which countries are showing the most enteric fermentation? That's a good question to look for in the FAO stat and in that database of food system emissions. And then on the profits and then finally pricing, this is more than on the product end, right? All the way. And this is like on those in that food systems diagram with the boxes, that part of what policies, right? So then from thinking about what policies can you all recommend from your policy program that you would say to the UK government, well, you do want to, what pricing would you put on to make it happen, or what else? And so another thing I can send, so I'm trying to, so we'll send a few things. So when the Biden administration came in, our policy, so we work with policy specialists from SIPA, at School of International and Public Affairs. It's a policy school. And they have this great table of 11 ways, 11 policies that the Biden administration could reduce greenhouse gas emissions from the food system. So that's another great potential homework assignment. What would you say? What would you advise the UK government to do?
Excellent. And strike when the iron's hot. Hey, as you said, take those opportunities to offer those.
Absolutely. Absolutely. Beginning of administration is very, very important. You have to get it ready a little bit before, but you have to do it right away, because that's one of those, like, window is open, you got to dive through.
And the word is that may happen in the UK next year, but we'll wait and see. There may be a
all right, we'll see.
But we'll wait and see. Anyway, so we'll move to another 3 questions. So another anonymous attendee said, when calculating the greenhouse gas emissions for the food supply processes, does it include the carbon sequestered in the biomass and stored in soil? So second question is from Siram Natadran. My audio is not working, so I'll rely on the captions to know the responses to my question, which is where. So Elaine, if you could pop the answer to this one in the chat or the Q&A, that would be excellent. So the question is, where and what is the role of the farmer of developing countries in this major issue of food systems adaptation to climate change? And then third question from Lucy Powlett. What is your take on vertical urban farming as one of the solutions to 1, reduced agricultural emissions by growing locally, and 2, reduce land surface use? Thank you for this wonderful presentation.
Okay. Wow. Well, these are all such great questions. Really terrific. By the way, I have to tell you one thing before I quickly answer when we go to answer these. My son lives in London and his family. So I do come sometimes. So maybe I can come and meet you in person.
That would be wonderful. We'd love that.
Yeah. Although during COVID we couldn't go very much. But also, where in London are? So here's just a quick question as we take a break, as I'm gathering my thoughts for these 3 questions, which I think we're okay on time. We still have a bit of time. But where are you? Where in London is the food system program?
So we're at City University of London, and we're based in Islington, specifically at Angel in London.
Okay.
So just north of the centre of London.
Okay. So I know where that is. My son they live in the Barbican, and when we go, we stay in Clerkenwell. And I think they go to the grandsons go to school in near Angel. So I know where you are. So I always like to know where people are.
Yeah.
That's kind of like all in the same area. So that could possibly work. Okay. So now let's go to next set of great questions. Food system emissions, is the carbon sequestered in the soil included? And the answer is yes. If we went back, let's see if maybe I can pull it up again. Let's just do it this way. Let's see, what's the easiest way so I can find it. Here we go. Okay, so the carbon sequestration part is included in a couple of ways. There's there's soil in the deforestation part, in this whole food related land use part. Soil is considered here, and then soil is also included here in the crop production. So that's where the soil carbon sequestration is in this approach. We're also going to be bringing together the carbon model, carbon sequestration, soil carbon, organic carbon modelers to start protocols for a multi-model approach. It's very important because there's been a lot of controversy about whether the soils can really do it, under what on what conditions. Farmers want to. In the U.S., there's policies. It's very policy relevant question, because they want to pay the farmers to sequester carbon. But unless they have a really solid base for, well, how much did you sequester on your farm? So this is a very hot topic right now. So AgMIP wants to help on that. So we're actually in June. We actually were just meeting with someone yesterday about it. We want to gather the groups who do it and develop protocols with them, so we can actually get that science-based, those metrics that have greater credibility, because then the policies can actually work. Otherwise, it's really very challenging. So that's the carbon sequestration story. The farmers and smallholders, incredibly important. It's millions and millions of smallholder farmers around the world who farm on, sometimes the definition is less than 1 hectare of land. And there's a great deal of attention on the role of the smallholder farmers. Some of the aspects, remember we had the crop biodiversity question earlier, because some of the smallholder systems with multiple use with like small plus with different crops, different vegetables, fruits, vegetables, as well as protein crops. This has potential to be very resilient to climate change. So, but at the same time, the work, for example, in Africa, as we were showing, and around the world, is that there's real vulnerability there too. So the session that I took part in earlier today is a new program which is focused on smallholder farmers in Africa. It's called VACS, VACS, which is being started by the U.S. State Department. And it's called Vision for Adapting Crops and Soils and then it's focused on smallholder farmers in Africa, and it's focused on traditional and indigenous crops, because they gave us this list of, like, I don't know, 300 different crops. It's across the food basket, by the way, too. It's not just grains. It's fruits, vegetables, tubers, roots and tubers, legumes, all the whole range of crops. And they said, oh, well, do you have models for 300 crops? I'm like, no, we don't have them, because you can see there's just been so much focus on we call it the big four crops. And but to really solve climate change for smallholder farmers, this program aims at significantly ramping up investments in the traditional and indigenous. Sometimes they're called orphan crops. Anyway, so definitely thanks for that question on farmers and smallholders. Crucially important. Okay, next one. Okay, that's from the rural setting to the urban vertical farming. Okay, so vertical farming is great. It's like fantastic. But you have to be careful, because and this is the same thing about local. locally grown produce is wonderful. We can know our farmers. I think they should pay local farmers to sequester carbon so we could know our own local soil carbon sequesterers, right? To this whole food really revolution that's happening now, so many places. But here's the but for both vertical and local, and which they're combined, is you have to make sure that they're not having a lot of greenhouse gas emissions in the way that they're growing the crops. So, for example, if it takes a lot of fossil fuels to run the ventilators in the vertical farms, then you may not get, and you may not be, anything that you might be saving for because it's local might be offset by the fossil fuel energy use. So this is another great student project to do a life cycle analysis of a vertical farm, right? And say, how are they doing their energy? How are they doing their light? Are they, right, their light? Are they, how are they doing their water, right? What are they doing with waste? And so there's been a lot of work on making those systems as close to zero carbon emissions as possible, but you just have to be a bit careful. For example, tomatoes, like I'll give one example. This is, let's say, on the locally grown. So let's say this, so we go to we have wonderful farmers markets. I'm sure you do too in London. And we go to, and we go to a farmer and they're selling tomatoes. Were these tomatoes grown in a greenhouse? Because I take my students to local farms and in the Hudson Valley. And so one time we went and the farmer very proudly showed us his greenhouse that was growing the tomatoes in the greenhouse. And and who knows, they may be pumping a lot of, in Israel, they use high CO2, pumping high CO2, the water, the ventilation, there were the motors running, it's like, wait a minute. So, you buy these beautiful tomatoes in the farmer's market, but it may not be helping. So you just have to be a bit careful. So it's a wonderful student projects.
That's excellent. You've given us lots of potential dissertation projects for our students. We're loving it. So it's excellent. It's dissertation time of year as well. Right. We've only got 6 minutes left. So perhaps if we try 2 quick questions and then I might ask the final one, if that's okay, Cynthia.
Perfect.
So Natasha Grist has said, can you say more about this modelling and how it might work in practice? And do you feel that there's anywhere across the world that is doing this effectively and applying, what your models are finding and suggesting? And then Lena Mahi has said, what are you asking of the for-profit dairy and meat companies who are present at Aim4C? And what are you asking them about needing to shift to more plant-based diets? Or I guess, are you asking them? And then my very final one was, I'd like to know, you posed us a question, and I guess I wouldn't mind hearing what your answer to that was. So how do you think that we could create a large-scale climate change solution? And, what's the role for research, policy, advocacy in that?
Wonderful. Okay, great questions. So all of them, the entire set were wonderful. Yeah, we should. Yeah, it was wonderful. We should, thanks. I guess you captured the questions. It's wonderful. All right. So this one was also this number one question about where is it happening? Where has it been successful? Where is it effective? Very, very good question. Very to the moment. This is exactly what we have to really prove. And this was, by the way, very much a frequently asked question. But when I got the prize, so I would say, AgMIP, we're doing all this great stuff, and they would say, okay, well, it's like, we can't sort of say this anymore, but it's like, where's the beef? It's like, where is it really working? So we have, the way AgMIP works regionally, I showed you that pedal on the regions, is that, so we have long-term AgMIP teams in, not everywhere, but from these various projects in Zimbabwe, in Senegal, in Ghana, that have gone through several cycles of this developing the long-term relationships with the stakeholders and the national stakeholders. We've also done it in Pakistan, in which then the teams are really able, they carry on, even if we don't have a funded project, they carry on the relationships, they carry on the methods, and address other questions that their stakeholders are asking them. We have similar similar approaches that have these long-term relationships is what's really needed, and we do have that in not every country that we've worked in. But we're continuing to work and develop, like in Latin America right now, in the Caribbean. That's where we've gotten the most traction, but we very much want to continue. We have strong participation in Asia, Japan, Korea, and China. So those are some of the places where it's actually working. But it's in that modeler, policymaker relationship. Okay, this is a very good question for Aim4C, and how they're dealing with that. So our project is entirely plant-based, which is very telling, actually. I think that, I think probably as we think about how things are going in regard to developing funding and investments, this is an example of a plant-based one. The whole dairy and meat, this is what I was saying about it's so challenging for those industries, right? What can they do? And it's, by the way, it's industries and countries, right? New Zealand, Ireland, right? It has a huge dairy. I believe you're right next door, so you know more than I do, but from my work with the IPCC and the delegates from the different countries, I would say also the developed, and Brazil also working so hard to figure out, and I guess this is what I would say finally. So it's very challenging. That's number one. Number two, I think creating, like, beginning to back down. It's like there's something, you may be familiar with the wedge approach for reducing greenhouse gas emissions. This came from the fossil fuel, and this came from the energy. Okay, how is it going to, so there's efficiency, right? There's renewables, there's, and then there's switching from high emitting to lower emitting. So I think having that kind of fan diagram approach for the meat is what actually, that's what we have to do. That's another, by the way, that would be that's really a project to say, okay, we're taking where it is now. Here are the emissions. What are the ways that we can address this? There's feed efficiency, right? There's a reduction of herd size. There's what are the actual mitigation packages that can help those practically back down, and then, developing alternate as plant-based in some places, maybe not all, but in some places, then plant-based begins to take over. Also, they're ready to be able to have a just transition away from meat. I think it has to be like that in a trend. I think planned transition is what to do. Okay, final one. Large-scale climate change. All right, final thing. And I know we're right at time. So here's Christina, what I would say. For example, for you and your students, rather than maybe each person choosing a different topic for their dissertations, maybe working together to create a plan, and maybe London has it because you guys are ahead of the US for sure. You know, we've had various ups and downs here. Maybe you have this already. Is there a net zero emissions food system plan for London?
And there's various different plans, but I wouldn't say that there's one grand plan.
So how about the grand plan? And each student takes a different piece of it, right? That they can do their own work around a separate piece. But then when you put it all together, see, that's the idea. And you need to have some radical collaboration and work together in teams, the collaborations, the teamwork, you know, but each person gets to have their own piece, right? Because then you have to get your, you know, tick mark and your check for your dissertation. But it's all been, you create a framing diagram so that each dissertation contributes to the grand plan for zero emission plan for the food system of London.
Excellent. I love it. I'm going to take that back to Dr. Rebecca Wells, our program director, and see what she thinks. It's wonderful. Cynthia, thank you so very much. Thank you to everyone for your questions. It's been excellent. I'm sorry we didn't get through them all. That was just wonderful presentation and overview of you, Cynthia, Cynthia. Thank you. We are absolutely delighted to be one of your final seminars on your year of presenting. So thank you for delivering an excellent presentation and a wonderful Q&A session for us this evening. We thank you very much. Just a final comment from me is to say, please don't forget to join us on the 13th of June for Shukuntala, Thilstead. I'm sorry, I've tripped over that name 3 times now, who, as you said, Cynthia, was the World Food Prize winner in 2021. So she's joining us next month. So thank you very much. How lucky are we to have back-to-back World Food Prize winners. So thank you again, Cynthia, very much. And we look forward to continuing a potential collaboration in the future. We have attached the information about your workshop in June in the chat. So for others to look at. Yeah.
Wonderful. Thank you so much. All the best. Good luck, students. All the best. Thank you, Christina. Bye.